In this video, we're going to introduce another way of looking at categorical variables when there's two categorical variables, and that's a contingency table. And we're also going to kind of sneak in some other probability topics that are going to be coming later on in this quarter. And goodness, it's like I'm in Back to the Future. My body is disappearing. Someone save me. Yeah, I think he has to save himself. Well, he saved his brothers. I hope my brothers are doing something in the past to renew my existence right now. So using data from a statistics class, we have data that was collected on whether students like chocolate and whether they like espresso. Not espresso, espresso. All right, so here's the data. So you can tell, just let's take a moment and interpret this. What does this number mean right here? This means that 11 people liked chocolate and liked espresso, right? But down here, this is the total number of people, the total number of students who liked chocolate. Because there were 11 that liked chocolate and liked espresso, and there were 7 that liked chocolate and didn't like espresso. So in total, there are 18 students who liked chocolate. And you can kind of do this, that's one way. Or you could look at it the espresso, right? There's 18 students who liked espresso and chocolate. There are 4 who liked espresso and didn't like chocolate. So there are 15 total students who like espresso. And that's kind of how we can interpret this table. Let's start by talking about marginal probabilities. Marginal because it uses the numbers in the margins is one way to remember it. And then there's a lot of other things we could say about that, but exciting stuff for another day. What proportion of the students like chocolate? So it's asking for a proportion. So that's going to be how many like chocolate over how many students there are. N, if you will, sample size. We just have to figure out each of these things. So here's where things are a little dicey, right? There's a total here, and there's a total here. What's our actual N? What's the actual size of the class? How many students are there? Well, we have to look at 23, the total of the totals. Okay? There are 23 students total. And indeed, right, if you look at all 4 of these possibilities for students' answers, this is going to add up to 23. Maybe the same 23 students that we pulled eye colors in the last video. So we're going to say, all right, there's 23 students total. How many like chocolate? Well, 11 like both, and 7 like chocolate and don't like espresso. 18 students total like chocolate. This proportion like chocolate. 18 out of 23 like chocolate. And this should be consistent. This would imply that 5 out of 23 don't like chocolate. And again, if you look up here, there are 5 that don't like chocolate. Okay, so that's our answer. That's a proportion. Make sure it's a simplified fraction, right? In this case, it is simplified, so that's good. But always verify. What proportion of the students do not like espresso? We have to find. Doesn't like espresso, it's right there. What proportion don't like espresso? Well, there's 8 students who don't like espresso, right? 7 students here and 1 student here for a total of 8 students. Well, then there are 8 students that don't like espresso out of a class of 23. This is already reduced. That proportion. And again, you could answer this as a percent, but usually, well, it's not really that consistent. Percent or fraction is okay. If I ever have a problem and want one or the other, I will let you know. Okay? Let's do some more. So again, this kind of restates what I said earlier. These are called marginal probabilities because we use the numbers in the margins. They use the total for a single variable. All right. So that's one of the, we just looked at proportions right now. And you said, Jason, we only looked at proportions. We didn't look at probability. What's going on? You'll find out later. Okay. Next, we're going to talk about joint probabilities. So let's look at some proportions again. No probability yet. Oh, goodness. No probability yet. And let's use something that we call joint probabilities. And a lot of times we associate that with the word and. So what proportion of the class likes espresso and chocolate? And again, we're looking at everyone in the class. So let's start by just writing 23. We know there's 23 students in the class. Espresso and chocolate. So here's everyone that likes chocolate. Here's everyone that likes espresso. What's the overlap? The overlap is these 11 students who like chocolate and espresso. So that's what we have. The proportion of students that like chocolate and espresso is 11 out of 23. What proportion of the class does not like espresso and does not like chocolate? So up here, it was the people that liked both. And down here, it's going to be the people that liked neither. And again, we're still talking about out of the whole class. So how many people don't like either? This is the value for doesn't like chocolate and doesn't like espresso. This is the overlap there. There's only one student that doesn't like either in this class. Okay? It's only going to be 1 out of 23 right here. All right, these are called joint probabilities. They're an intersection, just like how I kind of did that little graph, right? And I said, oh, where's the overlap? The overlap was right here. The intersection or overlap between two variables. And a lot of times we associate this with the word and. This is going to be big in a future video. And. The last one we're going to talk about in this video is conditional probabilities. And this is a little bit more tricky. What proportion of the students that like chocolate also like espresso? So right here, we're no longer looking at all the class. We're only looking at these students. Okay, not the whole class. So in the previous ones, we started by just writing that 23. But in this one, we're only looking at the students who like chocolate. So this is like espresso and chocolate divided by only like chocolate. What proportion of the students that like chocolate also like espresso? So we're only looking here. What proportion of these students also like espresso? 11 out of 18. 11 out of 18 is going to be our answer here. Okay. We'll talk more about conditional probability in a future video. But in the meantime, be very careful with the wording here. What proportion of the students that like chocolate also like espresso? 11 out of 18 students who like chocolate also like espresso. Okay? These students have nothing to do with this question. It's only asking information about people who like chocolate. Let me know if you have any questions, and good luck.